Good evening everyone. We are having a class today. So I think I already told you that chemistry class by NEET is on Monday and Tuesday 7 to 8. Yesterday we had a class about the chemical bonding, isn't it? Am I audible? Please tell me. Yes, I think I am audible. Let's start the class. So just quick review for the previous class. So 2 days back, this is the third class, sorry, of the chemistry. So in the first class, we just discussed about the chapter that is chemical bonding and molecular structure. That is chemical bonding only. Molecular structure part is not yet started. Will today start. In that we have discussed that atoms or elements or chemicals exist in two forms: free state, combined state. Why? The reason is because of octet configuration, which was given by Lawson and Lewis. Octet rule came. It gave the two definitions for that, and we'll start forming in this when the so after that we had discussed bonds. So bond is nothing but attractive force which hold the two atoms together. Types of bonds: ionic covalent, coordinate covalent, the properties and the definition. And the last, secondly, after that we have discussed the limitations of octet rule. There are 5 limitations majorly, and the bond parameters, and the majorly which is important is bond order and isoelectronic species. Isoelectronic species is very easy, the compound which have same number of electrons. So please remember, whenever the iso word comes, iso refers to the same. Okay, electrons are same, hence they call as isoelectronic species. So after that I discussed that scientists claim that ionic bond is not totally polar, it is also having covalent bond character. Even covalent bond also have ionic bond character. So which is described by two different parameters. One is Fajans rule. Fajans rule describes about the covalent nature of ionic bond. So ionic bond definitely will have covalent bond nature, right? Covalent nature. How much the covalent nature, which is described by Fajans rule, that is covalent nature is directly proportional to anion size, directly proportional to charge, inversely proportional to cation size. Even we have discussed certain examples here, right? Here also we have discussed examples. Hope it is clear, right? Let's talk about, and today we'll be finishing the part known as chemical bonding, and we'll even be starting the molecular structure. I think I already told you that this chapter is must and very important, because all blocks elements are going to be easier for us when we study this chapter. Okay, let's continue the topic. Yesterday we finished till Fajans rule. Today we'll be talking about dipole movement. So if you remember Fajans rule, I told you that Fajans rule says the covalent nature of ionic bond, right? So what do you think ionic bond is? What do you think ionic nature of covalent bond is described by? It is described by a parameter known as dipole moment. So what is dipole moment? Simply, it is reverse of or ulta or opposite of Fajans rule. That means it describes about ionic nature of which bond? Covalent bond, isn't it? It describes about ionic nature of covalent bond. Reverse of Fajans rule. And let me tell you, there were the questions in your NEET recently from dipole moment. Each and every part of this chapter is important, but I'm just telling that dipole moment questions came in NEET. So it describes about the ionic nature of covalent bond. Let's take the example of the covalent compound and we'll just check how much ionic nature is there. How do we describe? First, let me write the examples for ionic bond. I already told you that HCl is covalent bond because hydrogen and chlorine are sharing the electron. Even HF is also, covalent. HCl is covalent bond because there is sharing of electron, and HF is also covalent bond as there is a sharing of electron. I hope I already cleared that why it is covalent bond. So these both are covalent bonds. But the scientists said that definitely some will be having more covalent nature, less ionic nature, more ionic nature, less covalent nature. So how do we describe here? We see that you can see that here two atoms H and Cl, here H and F. In these both cases, hydrogen is similar and hydrogen attached to electronegative element, right? And as the chlorine is electronegative element, it tried to attract the electron toward itself. It will not take away actually, it will just attract the electron toward itself as it is electronegative. Hence, how do we show that actually? We can show by many ways. One, by showing the head of the arrow towards the electronegative element, that is towards the chlorine. Or one more way of writing this is, as electron is moving towards chlorine, it develops negative charge, but we will be writing as partial negative. To be specific, why we are writing partial negative? The electron is not totally moving, it's just moving towards chlorine, not only taken totally by chlorine, it's just moving, okay. Here hydrogen will be giving, hence we write as partial positive charge. There are two ways we wrote. One more way of writing is, you can show the electron as it is moving towards the chlorine. So there are three ways, but the most acceptable way where we in a chemistry is this. You can write any way, it's not an issue, but the second one, middle one, actually is the most commonly used in a chemistry. Similarly, for the same, here I can write towards fluorine, I can write partial negative here, and here I can write partial positive here. Similarly, that means these two compounds, as they are covalent, but they are also having the charges. Whenever they have charges, they are called as ionic. That's why, because of the charge development, we call that compound has ionic nature of covalent bond. Though bond is covalent, it is showing the charges. Hence, we are telling that covalent bond has ionic nature also. We are just confirming with the charges, right? Okay, we described that covalent bond has ionic nature. But let us just describe what is dipole moment actually. The dipole moment actually is, so if you see that HF and HCl, both in this case, this is fluorine electronegative element, positive, here partial negative charge, okay. As the two compounds are different, there will be definitely something will be different, right? You can see that as of, you might know halogens very well, right? Halogens are how many? 4 are there, majorly 4 are there, 5 are also there, but one we, don't talk about. 4 majorly are fluorine, chlorine, bromine, iodine. As down the group, electron negativity decreases, right? That means fluorine is the most electronegative element, iodine is the least electronegative element. So I already told you that I'll be here dealing with a periodic classification or periodic table, what the chapter which is there in your first year. I'll be dealing that chapter here itself. Please remember, as we move down the group, electronegativity decreases. That means chlorine is the most electronegative element. That means it will take the electron towards itself readily, or you can say fastly. So better say clear for the namesake, or for the namesake, what I am doing here is I am putting the bigger charge. Actually, should not be such case. I am just showing to make you understand. I put the negative charge more, okay, compared to the chlorine, because chlorine is comparatively less negative compared to the fluorine. Hence, the partial negative charge will be less. That means these two elements are differing in the magnitude of the charge, because the charge will be more in fluorine. Magnitude means quantity. So that means these two compounds are differing in magnitude of the charge. So I am here taking Q for charge or magnitude of the charge. One more difference between these two elements is bond length. Obviously, two atoms are there, two different compounds are there. Bond length also will be differing, right? So these two compounds are only differ by two ways. One is by charge density or magnitude of the charge, which is represented as Q. One more difference between these two molecules is distance. So if I multiply the differences, what are the differences? Charge and distance, or the bond length. Charge and the bond length if I multiply, or you can even say distance, that is called as nu is nothing but dipole moment. So what is dipole moment? If you dipole moment, it's a product of magnitude of the charge and distance between two atoms. So if you multiply the charge and if you multiply the charge with distance, that is known as dipole moment. Okay. And let's be specific in defining dipole moment. And as you can see that dipole moment has direction, right? Where the dipole moment towards will be here, it will be towards chlorine here, and here it is fluorine again. Fluorine will create the dipole moment. So you can see that dipole moment has direction. So the thing which have direction are called as vector quantity. So if you describe dipole moment, so let's describe or let's define dipole moment. Dipole moment ka symbol I'm writing. What is this? It's a vector quantity. You know, every quantity is two type, scalar or vector. Scalar means will have only, you know, magnitude. Vector means will have magnitude and charge. Magnitude and direction. Vector means which have magnitude and direction. You can see that dipole moment has direction. That's why I'm writing as vector quantity. It is a vector quantity which is the product of magnitude of the charge and distance between two atoms. So if you multiply means here multiply actually. So if you multiply the charge value and the distance between these two atoms, you will get a quantity parameter known as dipole moment. Very, very, very important. So let's see HF and HCl. What do you think whether dipole moment will be, whether mu value will be more towards HF or HCl? What do you think dipole moment is more for HF or HCl? Absolutely, the answer is HF, because fluorine is most electronegative. That's why the charge magnitude will be more here. That means Q value will be more. If it is Q value is more, you can, the answer is, you know, mu will be more. Mu means dipole moment will be more. Hence, HF is having more dipole moment or more ionic. So let's write here few important things. And let me just go back and I'll tell you the units also. The units are also very important. You know, charge units. Units for this charge unit. Charge unit is coulomb, right? You might have studied in physics. Charge is coulomb, right? Distance is meter, right? So we write as cm. Don't write as capital C, capital M. It looks like centimeter. Please write big C, small m, which indicate that it is coulombs into meter. Okay. That means the units are coulombs into meter. One more unit is debye, D-E-B-Y-E, debye. As a scientist who discovered dipole moment was debye only. Hence, the one more unit is debye. So please remember that 3.8 into 10 to the power minus 30 coulombs into meter is known as 1 debye. Okay. So we have got two units. One is coulombs into meter. One is debye. One debye is always is equal to 3.8 to 10 to the power minus 30 coulombs into meter. So we have finished with the units. Let's go back to the properties, which was a asked question, and there are high chances of asking questions from this again. Properties of dipole moment. Mu is dipole moment. I'm writing short form here. So first thing, you can see that more electronegative the element is, if the element is more electronegative, it will attract the electron toward itself more. That means it will get the charge more. If it is having more charge, means it acts like more ionic. More ionic means more charge, means more dipole moment. So you can do one thing. More electronegative means more ionic. And lastly is more dipole moment. Right? Let's see the examples for this. Even GE means ask question from this point, first point. Electronegative means more ionic, more dipole moment. Let's see the example here. How the question they are asking. They are asking us to arrange HF, HCl, HBr, HI according to their dipole moment. Please answer. What is that? Please answer this question. Which is more dipole moment? HF, HCl, HBr, HI. What's the answer? Please arrange HF, HCl, HBr, HI according to the dipole moment. What do you think the answer is where? The answer lies towards what? Is it HI or HF or HCl or HBr? Kiran joined late. Kiran, why? So what is the answer? I'm expecting the answer. Please answer the question. I should only give. Okay, I'll just. So I already told you that more electronegative, more ionic, more dipole moment. That means fluorine is most electronegative element here. Hence the answer is HF is most, then HCl, then HBr, then HI. Okay, Kiran. Okay. That means the answer is yes, Vikram. Yes, Vikram. The answer is HF. But you are answering after I am giving answers, right? Acha. Right. The next one. So, and consider if multiple bonds are there. Here we talk about the example like HF and HCl, which have only single bond. If multiple bonds are there, every bond will have dipole moment. So, in that, if you have multiple bonds, we will calculate the resultant dipole moment. Example. Don't worry, we have example. Example like H2SO4 if you take. The point is not necessary to write. I'm just explaining here. Like if you have H2SO4, if you see the structure for H2SO4, it is like this. So this sulfur and oxygen mein electronegativity is most for oxygen, hence the head of the arrow towards the oxygen. In the case of sulfur and oxygen, again the arrow will be towards oxygen because oxygen is the second most electronegative element in the whole periodic table. Hope you know. If you don't know, I'm writing the sequence for the electronegative element here. The most electronegative element is fluorine, second is oxygen, third is nitrogen. Fond, remember, fluorine, oxygen, nitrogen. Between sulfur and oxygen, it is oxygen. Between sulfur and oxygen, again oxygen, that means it is moving towards oxygen. Again, sulfur and oxygen, oxygen, oxygen. So, if you have multiple bonds, each bond will also have dipole moment. In that, you will calculate the resultant dipole moment. You will sum up all and you will get the resultant. Okay, that is very easier thing. That's, I think, no need to write that point. But to explain the further second statement, I just gave you that explanation. So let's continue with the second point, which was only the asked question in a NEET. That is, remember that if the molecule is having linear shape, linear and tetrahedral shape molecules or compounds have zero dipole moment. Okay, if the molecule is having linear shape, if the molecule is having tetrahedral shape, the molecule definitely will have no dipole moment. That means zero dipole moment. How do we know the molecule is linear or tetrahedral? Don't worry, in the next part of this chapter, that is chemical bonding and molecular structure, you will be able to write the name. I mean, you will be able to learn. क्या बोलोगे इसको? What will you say? You will get the shapes of all compounds. Don't worry, you will have the we'll study the trick to know which compound is linear shape, which is tetrahedral, which is trigonal, pyramidal, all the shapes. So, but as of now, remember, linear and tetrahedral shape, जिसका shape linear होगा, tetrahedral होगा, they definitely will have zero dipole moment. Let's see the examples for this linear shape. By the reason they have the zero, that also we are going to study here. Let's see the example, which is carbon dioxide. So carbon dioxide is CO2. If you know the CO2, it is it is linear shape. Oxygen is to the right side, one oxygen to the left side. So I already said that if bonds are there, multiple bonds are there, we need to calculate the dipole moment between two atoms. So carbon and oxygen may weigh the electronegativity towards oxygen, right? Hence the arrow will be towards oxygen. Here also towards oxygen. So you can now see that between C and NO, the arrow is moving towards oxygen. That means the one arrow is towards right side. Here oxygen is again taking the electron towards itself. Hence the arrow is towards left side. As the two atoms are similar, not so different, right? One jagah pe oxygen hai, other jagah pe sulfur hai, right? They both are similar. Hence the value of dipole moment will be again similar. If it is positive dipole moment and it is negative dipole moment, that's why they cancel their dipole moment, because the heads are moving towards away from each other. They are moving away from each other. So they are cancelling their dipole moment as the direction of the arrows is towards opposite side. Hence they have resultant dipole moment will be zero. I hope you got the reason why linear molecules have zero dipole moment. The reason is the heads are moving opposite side. As the things are moving opposite side, they definitely will cancel. Hence linear molecules will be having zero dipole moment. Let's talk about the example related to the tetrahedral shape. The tetrahedral shape, there are many. So tetrahedral shape is diamond shape. So example, if I take carbon tetrachloride, if you draw the shape, it will be tetrahedral, that is diamond shape, tetrahedral. It will be like this. Now, so every bond should have dipole moment. So we are calculating between carbon and chlorine, the head will be towards chlorine. Between carbon and I'll put in the arrow here. Chlorine move downward. So एक ऊपर जा रहा, 3 are moving downward, right? And they are totally not moving downward. They are slightly moving away from, they're slightly moving downwards. The resultant of this 3 will be down only. Hence, you can see that above it is moving up, it is moving down. Again, both are cancelling their dipole moments. Hence, the carbon tetrachlorides also have zero dipole moment. I hope it is clear. Is it? Is it? So we said that linear and tetrahedral molecules have zero dipole moment because they both cancel their dipole moment as the arrows are opposite directions. Let's talk about the third important property of a dipole moment. Do you remember the first point of the dipole moment? I said more electronegativity, more dipole moment. Let's check. Is it applicable every time? I have a question that NH3 or NF3, what do you think? Which one have more dipole moment? Please. Kiran, let's go back. We're telling why one arrow is upward. You can see, can you see the structure of the molecule? The structure is such that 1 chlorine is above, 3 chlorine are slightly downwards, not totally downward, they're slightly downwards. Hence, carbon chlorine ke beech mein electronegativity is more towards chlorine. Hence, the arrow is upward for that, right? Because carbon and chlorine mein chlorine is most electronegative, na? Hence, the arrow is upward, isn't it? यहाँ पे chlorine नीचे तो downward move arrow होगा, isn't it? I hope you got. Right. Now I have a question. NH3 and NF3. NH3 or NF3, which has more dipole moment? That was the asked question about your NEET. Even they ask about carbon dioxide in NEET. Even they ask about NH3, NF3 and BF3, which we are going to discuss further. Right. How? Please answer NH3 or NF3. What do you think the answer is? More dipole moment is towards NF3 or NH3? The answer is NF3. Yeah, Vikram is telling the answer is NF3. We are expecting the answer to be NF3 because fluorine is most electronegative element. But here, let's see the answer is same or not. Let's see. Let me write the structure of NH3. NH3 has pyramidal shape. Don't worry. These shapes we are going to memorize. We'll learn that in the next half. And you know that whenever nitrogen forms 3 bonds, it will have one lone pair, isn't it? And so these are the two structures, both have the same shape, that is pyramidal shape. The one thing here is, one more thing you need to study here is, every lone pair is also acting as a bond. Lone pair is also counted as bond. That means it also will have dipole moment. Let's see. First thing about NF3. Here in NF3, nitrogen and fluorine के बीच में electronegativity towards fluorine. The arrow is moving downward. Downward again, downward. Okay. And between nitrogen and lone pair, it is moving towards upward. Oh, upward. Because nitrogen oxygen lone pair में से lone pair will have more electronegativity as they are alone, right? Right. So one is moving up, 3 are moving downwards. Here if you take nitrogen, hydrogen, as you know, FON I said. N means, F means fluorine, O means oxygen, N means nitrogen. That means nitrogen, hydrogen में nitrogen will be having more electronegativity. The arrow is moving upward, upward, upward. Here nitrogen lone pair में से moving upward. Here you can see that one is moving upward. Here 3 are also moving upward. One is moving upward, 3 are moving downwards. That's why, though the electronegativity is more for fluorine, the arrows are somewhat cancelling, not total cancellation, not total cancellation. Please remember, as 1 is above, 3 are down, some amount of dipole moment is getting cancelled because of lone pair in NF3. Hence, NH3 has more dipole moment than NF3 unexpectedly. Right? We were expecting NF3 because it is having more electronegativity. But the answer is NH3 because the some amount of dipole moment is getting cancelled here. That's a reason here, right? Okay. I hope you both all got the explanation why NH3 is having more dipole moment, though fluorine is most electronegative. Though it is most electronegative, the upward arrow is cancelling some amount, hence it is getting lowered. Right. So, right. Fourth one. I told you that linear and tetrahedral molecules always have zero dipole moment. One more exception we have here is, these are called as exceptions, definitely. Right. One more example we have is BF3. Let's see. The BF3 is trigonal planar shape. Sorry, trigonal planar. Sorry. So if it is, the structure is like this. Okay. Fluorine and bromine. Obviously fluorine. Again you can see one is moving up, these two are moving down, both will cancel. That's why we say BF3, though it is not linear, though it is not tetrahedral, it has zero dipole moment because two atoms of one fluorine is right side or left side, the rest are opposite side, hence the cancelling the dipole moment. Though BF3 is not linear, not tetrahedral, it is trigonal planar shape, and NCERT has mentioned only 4 examples in a dipole moment. All 4 examples have mentioned, asked in your entrance exams. So you can now analyze that. They are totally asking the questions from NCERT, right? This question also asked, third one also asked, second one also asked question. NEET ask questions, Mains ask questions. So every example which the NCERT is mentioning, they have asked the questions. I hope that every moment is cleared. Let's write the example one more. You are going to tell me that answer. The ring which I am drawing here, I can't draw the properly benzene here. Benzene, the structure is should be proper. When you write the structures, benzene should be hexagon with a circle inside it in the center. Oh, sorry. You are going to tell me the answer for this fifth one. Though it is inorganic chemistry, but I'm giving the organic chemistry example because they're also asking the dipole moment related to organic chemistry, so we can't leave that this questions. Let me tell you that the structure which I'm drawing, the benzene, this is known as benzene. This is known as benzene. Benzene attached to 2 chlorine here, 2 chlorine here, 2 chlorine here. What is the thing changing here is 1 chlorine is moving away, 1 is together. One more, alternate position, opposite position. Let me tell you the simple thing. If 2 things on the side by side in the benzene, like this one, this side by side means this next to each other, this position is known as ortho. That means this is ortho compound. Ortho, O-R-T-H-O, short form you can write as O. If 2 groups on the alternate position, leaving one carbon, they are called as meta. M short form. If they are opposite position in the benzene, this ortho, meta, para, These words are referring only related to benzene, not anywhere else. That means this is dichlorobenzene, this is metachlorobenzene, this is parachlorobenzene. Right? Simple. If in benzene, if two groups are on the same site next to each other, same side means next to each other, they are ortho. If they are at alternate position, they are called as meta position. If they are at opposite position, they are called as para positions. Okay. I have a question. Ortho, meta, para में which has higher dipole moment? Please arrange their dipole moment accordingly and answer. Arrange the dichlorobenzene according to their dipole moment, whether it is ortho, whether it is meta or para. Please answer fast. What's the answer? Guess. What do you think dipole moment is more for where? More where? You can't. Look here. Obviously carbon and chlorine में chlorine, carbon and chlorine में chlorine ही होगा arrow towards chlorine. I think now you can, with the help of arrow, now you can predict the answer, right? With the help of arrow, you can now tell the answer. What do you think the answer is? Where the answer is? Is it para? Is it meta? Is it ortho? Kiran is telling all the dichlorobenzene. The answer is right. Because I think with the help of arrow you can say, you can even predict, because in the parachloro wale mein, there's two, one is up, one is down, cancelling. That means although dichlorobenzene is more than meta than para. Okay. Now, this question they are asking. One more sort of question which they are asking utilizing the concept of dipole moment. They are asking which compound is more. This sequence is for dipole moment. I want a similar differences for ionic character. What do you think more ionic is what? Is it ortho? Is it meta? Is it para? Kiran, very good. You answered right. What about Vikram and other students? They are also there, but you're not answering. I already told you more ionic, more dipole moment means more ionic. That means the answer again same. OMP, right? Let's just one more question. If they ask you covalent nature, do a reverse of this. थोड़ा complicated कर देंगे, but though it is very easier, I think this is about, it looks complicated for you because this, I think first time you're listening this word. The question is, arrange the molecules according to the lipophilic character. Lipophilic, do you know the meaning of lipophilic? Lipo is a word related to oil, right? Philic means attraction. That means these are the compounds are soluble in oil. They attract oil. That means they are polar or non-polar. They are non-polar compounds. Non-polar means covalent. Indirectly, the question is they are asking you to arrange compound which is more soluble in oil, more soluble in non-polar solvent, or indirectly they are asking covalent character. So please do reverse of this. That is P, then meta, para, meta, ortho, reverse. The concept is similar, that is dipole moment, but they are just framing the question utilizing this concept of dipole moment, like ionic character, which one is, they can even ask you which one is more polar, more ionic, more dipole moment, more ionic, more polarity. That's all. That means ortho, meta, para only. So you can see that they are framing many questions. Hope you got about dipole moments. Anything? Any questions? Very good, Kiran and Vikram. Very good. I hope you are getting the explanations. right? Let's do the last example, then we'll finish chemical bonding. Only chemical bonding we have finished with the dipole moment. Lastly, last example of dipole moment. This is of which exam? 5th, 6th. So I have like CH4, I have like CH3Cl, I have like CH2Cl2, I have like CHCl3. Leave the CH4, sorry, leave the CH4. And lastly is CCl. I have CH3Cl, CH2Cl2, CHCl3, CCl4. You can now look here that actually it was CH4, methane. Methane, this is methane. One hydrogen is replaced by one chlorine. Second, 2 hydrogen went, 2 chlorine came. 3 hydrogen went, 3 chlorine came. One all hydrogen went, 4 chlorine came. That's all is very easy. That means one chlorine is increasing. So I have like this compounds. Please arrange them according to the dipole moment. Lastly, we'll be finishing the first part of the chemical bonding and molecular structure, that is chemical bonding. Okay, the chapter is chemical bonding, molecular structure. We finish only chemical bonding. Please answer the 6th one: CH3Cl, CH2Cl2, CHCl3, CCl4. What do you think? You can draw the diagram. All have the tetrahedral shape. All of them have the tetrahedral shape. You can see electronegativity is electronegative elements are increasing. Okay, if you can't predict, let me just write. All have the same shape, tetrahedral only. But definitely they'll be having some less or more dipole moment. Here, down, 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 up. If one is up, one is moving up. The downwards are 3 which have the same nature. Same nature means 1 up is of chlorine, 3 ups are of chlorine. Both will cancel the dipole moment. That means zero dipole moment is found for CCl4. That means 0. So you can see towards chlorine, it is towards carbon, carbon, carbon. So all are moving up, and it will have more than this, than this. You can see simply with the help of structure we can just say. Simply remember, if electronegative elements are increasing, elements. So if you want the thing to be written here, number of electronegative elements increases, dipole moment decreases. Simply, it has one chlorine element here, 2 chlorine, 3, 4. I'm not telling electronegativity. Electronegative elements are increasing. Dipole moment will get decreased. You can see the reason, right? Yeah, Vikram said it very good. Yes, Vikram. But Kiran, why deleted? Wrong tha. So we finish all. We'll be doing questions. Let me just finish molecular structure. So the next part is molecular structures. Okay. For this part, you definitely need to keep the periodic table in front of you, right? Right. So what is molecular structure? The name says it's talk about the structure of molecule, right? The name of the chapter says here in this case we'll talk about the structure of molecules. In the chemical bonding, we just talk about the bonding only, how the bond is formed, what is a bond, it is more covalent, ionic, all the things we discussed. But what is the shape? We could no theories could explain, no bond could explain what is the shape of the molecule. Hence, what is the shape of the molecule is described by molecular structures, the molecular structure theories. So, molecular structure theories. To describe the shapes of molecules, three theories came into existence. That one first theory was Vsapr theory. I'm sure that you have memorized this answer in your first year. That is Vsapr theory. Most of you, I think, because this is the most common and easy, most important question for your IP. So first theory is Vsapr theory. Second is VBT, that is valence bond theory. T here refers to theory. The last is molecular orbital theory, right? Right, we'll talk about the theories in detail. Let's start with Vsapr theory. Vsapr theory. What is this theory says? Let's write its full form. What is it? V here stands to V stands to valence, shell, electron, pair, repulsion theory. And in chemistry, the things are very easier sometimes for us, because whatever the heading say, that is the meaning there itself. So no need to memorize the big postulates what for valence bond theory, so valence shell electron pair theory. The statements or the postulates of the theory are included in the are there in the full form only. The name says valence shell. Valence shell means last shell, electron pair. Whatever the electron pair in the outermost shell are there, they undergo repulsion. That's all. So this theory says, this was described by two scientists, Nilholm and Gillespie, but two more scientists came later and they extended this theory. That two scientists are Sidgwick and Powell. That means this theory was the contribution by four scientists, Nilholm, Gillespie, Sidgwick and Powell. No need to remember the names. I'm just giving the information. They won't ask you the name of the scientist of this theories. So let's write the postulates of Vsapr theory. First postulate is the electrons in the valence shell, or the valence shell is also known as outermost shell, experiences repulsion. Example, if oxygen is there, oxygen has 6 electrons in the outermost shell. So this, this as electrons in the same nature as there are electrons and they have the same nature, then they experience as more repulsion. The first statement of this Vsapr theory is the outermost shell electron undergo repulsion, right? Two, but you know what? They try to minimize that repulsion. If repulsion is there, molecule is unstable. So that's why they are trying to minimize the repulsion. To minimize repulsion, they arrange electrons in such a way that they give shape to the molecules? It's very simple. Oxygen always forms two bonds. Consider of oxygen is forming two bonds. If two, like hydrogen H2, you take H2. So oxygen has utilized two electrons. That means four electrons are there. That means two pairs are left. They can't be. The valence shell electron pair theory says this lone pairs or these electron pairs, they have much more repulsion. Hence, they cannot sit together. They cannot be side by side. You know, to minimize that repulsion, they means here electrons or lone pairs arrange electrons in such a way that molecules. So molecules arrange electron in such a way that while arranging, they give shape to the molecule. Let me just take the second statement. To minimize repulsion, then arrange electron in such a way that they give shape to the molecule. Right. So so this oxygen has two lone pairs, but these two lone pairs are very having a high repulsion, and they cannot be together. Hence, if you see H2O molecule, oxygen lone pairs, the lone pairs are far away. Whenever they are arranging the electron, while arranging the electron, they are giving shape to the molecule, isn't it? And please remember one more asked question. Which electrons have repulsion? They said that lone pair, this two electron and this two electron are called as lone pair. This lone pair, have highest repulsion. Hence, they cannot be side by side. Hence, they will be far away. They will be arranging, in a space in such a way that they will be far away from each other, and while arranging, they are giving shape to the molecule. Hence, we found that lone pair have more repulsion than lone pair bond pair. Bond pair matlab bond ke electron, and the least is bond pair have least repulsion. That's why two bonds can be side by side, whereas two bonds can be side by side because bond ke jo electrons hai, they never or they least undergo repulsion. Whereas if you take the electrons of lone pair, they have most repulsion. That's why they cannot be side by side. They should be very far away, right? First statement is covered. So we said that while arranging they are giving shape to the molecules. And Nilholm and Gillespie, the scientists have divided thus two types of compounds are possible. In the whole पूरे universe में पूरे world में ले लीजिए, we have only two types of compounds. Two types. First one, compounds having this is having lone pairs, and compounds having this is V, no lone pairs. That means in the whole universe, whatever the compounds we have two types of compounds. The compound which have lone pair and have no lone pair. So we'll now be talking about the compound which have lone pair and which have no lone pair, and along with their structures. Tomorrow I'll be continuing the topic of this. And those who are watching, if you don't have periodic table, keep the periodic table ready in the next class, that is on Monday again. So to get this theory, that is Vsapr theory. So I just left you in incomplete of the Vsapr theory. Okay. No, any doubts? We'll just keep here itself. If we continue, we have the many things to be studied and we don't have time to actually continue. So